Hello and welcome to 5-Minute Math. Today we are looking at the third grade concept of rounding. This is standard 3.2C in the great state of Texas, and we are using item number 14 of the Redesign Practice Online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a point on a number line. It represents the number of people at a parade. And we just need to find a statement that best describes this. So this point is the number of people at a parade. You know what? I want to be able to draw on this. So I'm going to open up my graph draw feature. I'm going to expand it and make it a little bit less transparent so I can see the problem behind it. I'm going to turn on my draw feature. All right, so now I can annotate, or I can draw all over this problem. So the point on the number line represents the number of people. So the number of people is right there, that point right there. So take a look there. We've got 8,000, we've got 10,000. We have a point in between. So 8,000, 10,000. All right, so this is going to be 9,000. We don't even know what that point represents. It doesn't really matter, but if we wanted to estimate, I'm going to think that's between 9,000 and 10,000, but it's, if I were to say halfway between the two, it would be like right there, so it's more than 9,500. So I'm going to, let's call it maybe 9,776. Right, it doesn't matter exactly what it is, but I'm just getting you a number that I think this kind of represents here. Right, so how does rounding work? Well, rounding is going to the next largest number. And so let's look at these four statements. This will kind of help us figure out how rounding works. So the number, every time it says the number of people, right, the number of people, the number of people, the number of people, the number of people, all of these number of people at the parade, this just means the dot. Okay, and what did we say our dot was? Well, our dot was about, our estimate was maybe 9,776. Okay, so we can read it that way. So the number of people at the parade was less than 8,000. Well, first off, that doesn't make any sense because 8,000 is right here. So less than 8,000 is going to be over here. Less than 8,000, and it is way to the right of that. It's greater than 8,000. But that's where, look at this. This also doesn't make sense. 9,776 is less than 8,000. See, putting that number in there really just makes that seem like a wrong answer. It's greater than 8,000 because of what's in the thousands place. All right, so it's not A. B, the number of people at the parade was greater than 10,000. Okay, well, here's 10,000. If less than 8,000 is off to the left, greater than 10,000 is going to be off to the right. And no, it's not greater than 10,000. It's less than 10,000 because here's your 10,000 and it's less than that. So once again, let's see what happens when we put the number in there. 9,776 is greater than 10,000. No, look, this has got a number, a digit in the 10,000s place. This has nothing in the 10,000s place. 9,000 is always less than 10,000. So B is incorrect. The number of people at the parade was about, okay, so we're going to get about. So now we're going to get into the rounding. Was about 10,000 because the point is closer to 10,000. Well, is that point close to 10,000 or is it close to 8,000? That's really what we're asking. Is this 9,776 closer to 10,000 or closer to 8,000? We'll just look at it. Look how close this is to 10,000. It's just it's got like one square, if we're looking at squares here, between the point and 10,000. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 9.5 squares to 8,000. So it is about 10,000, and that's what rounding means. It just means it's closest to that next largest number. It's about 10,000 because the point is closer to that. So we're going to turn that off, go in and answer C.